Welcome to another video of ADISRA SmartView. In today's video we will take a look at how to create database connectivity and use the data in various ways. We will start analyzing the engineering environment and how to create a database connection that will be later used in different places of the application. We will also check the SQL Server used in this demo, although other databases could be used too. Then we will execute the application to explain the features that were implemented, and we will do a full application analysis to explain it all. So let's open the ADISRA SmartView engineering environment and explore the application. I will use the launcher to open the pre-created sample application developed specifically for this video. My goal in this video is to provide as much information as possible to get you ready to create an application with database connectivity and be able to use the data in different ways. To begin with, let's open the database connection settings and check the existing SQL Server connection. As this is a sample application, I chose to use SQL Server, but we can create multiple connections to different database providers. The first required field is the server name, which I copied from the SQL Server Management tool. We will use the Windows authentication, and we need to select the database name. The database name app data was also created previously, and it already contains the application tables. So we will make sure the app data is selected and test the connection. In case it succeeded, you are ready to use this connection in different places in the application just by referencing the name of the connection. We will take a look at the running application now to understand the features implemented. It loads the initial home screen and provides buttons for navigation to different screens using a screen object. On the first screen we have a data grid object connected to a table in the SQL Server called machines. Let's take a look at it. It contains information of 10 machines and their production times, whether running, stopped, or other custom status. And that data can be seen in the data grid using a simple configuration we will see later. Another feature implemented on this screen is the animations at the bottom. Whenever the user selects a machine from the data grid, the bars at the bottom are updated to reflect their values. This second data grid added to the screen, instead of loading data from a custom table such as the machines, it loads historical data generated from the tag history document we will analyze later. The user can also interact with the selected data using the date filter dialog. To explore other alternatives, I have added an option to update the machines table on the database using a script. As soon as I click Update, a query will be executed updating the database. And we can also use the data grid to execute free queries. This dialog allows us to write queries and check the selected machines. As soon as I change the query, the data grid will execute it and update the data. Another common request is to export selected data to a CSV format, and we will see it later how to achieve it. The next screen contains a trend object which can be used to load online or historical data for multiple tags. Since the simulation is enabled, we can see the pens being updated. At the bottom, we can select different time ranges to the trend. It allows the users to change the configuration at runtime to make better analysis. The built-in charts added to this sample application display online and historical data. The bar chart and the pie chart displays the machine's run duration, and the chart on the bottom displays historical data generated by the tag history document. We can change the filtered data by changing the datetime pickers on the left. And the last screen is a bonus for you. It's not a built-in chart. Instead, I used an external JavaScript library to create it. Since we updated machine 4 while interacting with the data grid screen, as soon as I click Update, a new HTML file will be generated, adding the extra 50 minutes of test time to the machine 4 bars. I will go back and clear that value, and the HTML file will be updated once again with the current value. Let's analyze the application, starting from the tags document. You will notice that the first tag called machines is an array of 10 machines. The machine type contains the machine name and multiple status information as float tags indicating the machine's running time or stop time. The selected machine tag also represents a machine and will be used by the data grid screen to store the machine selected in the data grid. Some other tags were created for date filtering or for the navigation as the screen opens string tag. The query string tag will be used in the free query screen. The Boolean tag will be used to enable or disable simulation. Let's skip the graphics and take a look at the services first. The simulation, as mentioned before, will be enabled when the Boolean tag is set to true, and it will execute every 1 second, saving random numbers from 10 to 90 to the machine's run status. The tag can be changed by the checkbox on the left of the application. The startup service gets all the machine's data from the SQL Server and updates the machine tag array. The trigger document will also be responsible for getting the data from the database and updating the array tag, but it executes every 5 seconds. The user function responsible for creating database connectivity and selecting the data was created under a new library called dbHelper. The function getTableData receives the table name as a parameter and returns a table formatted as a list of rows, and each row is a list of strings for each column selected. It is a simple function that creates the select query and executes it using the database connection we have created earlier. The order of the selected columns will matter when reading the values from the list. We also need a tag history document in this sample app to store the tags which will be used by the trend, the data grid, and the line chart. It allows storing those values using the proprietary database, but for this demo purpose, we will use the database connectivity and select the SQL Server already configured and tested. I have configured the machine's running and stop time to be stored, and it generates a table for each tag as soon as the application executes. The table name indicates what tag it represents, and its structure is common to any tag history table. The timestamp column contains ticks and can be converted to a readable timestamp. I have created a function that converts the ticks, so it helps when analyzing the data. Keep in mind the version 4.1.1 will allow saving the timestamp into a readable format, and also save all tags into one single table. The trend object can easily display the data stored by the tag history document. We just need to add the machine's run tags that match the tags added to the tag history document, and during runtime the application will load it. Another object that can connect to the database through the tag history document is the data grid. Users can connect using the history type and add the same tags as columns, and during runtime the data grid will load the tag values. Some images were added to the application during the development, as you can see here. The last documents we can analyze are the user function libraries. The first library we have already looked, so let's check the next one. The HTML helper is responsible for creating the content for the HTML chart page, which contains all the machine's information. The code creates the entire HTML from top to bottom, adding the machine status of the tags. Let's go to the graphics now. The initial screen contains the screen object, which is set to load the home graphic initially, and will be used to navigate between the different graphics of the application. Each button on the left sets the screen, and it must match the graphic's name. The screen open tag configured here gets the name of the graphic currently opened and will be used to animate each rectangle, making them visible or not depending on the opened graphic. The next graphic is the data grid. It contains different usages of the data grid using database connectivity. The first object has a table-type connection using the SQL Server connection we have created. I selected the machines table, so I will open the SQL Server Management Studio and check the table. This is the data that the data grid will load without any filters, and we can confirm in the running application. You can also configure the data grid column properties such as the header, width, and alignment. To create the animation using the bar graphs for the selected row, I have used the on-while script of the data grid graphic and rectangles with dynamic fill property. The script will get the selected row and update the selected machine tag, and that same tags will dynamically fill the rectangles within the range 0 to 100. The data grid on the bottom uses the history type connection and displays the first two machines' historical running times. To filter that data, I created a dialog to let the user select the initial date to apply a filter. This same date time tag will be configured in the data grid filter settings. Another feature added to this video is to update records in the database using scripts. The selected button is configured to open a dialog, and it expects a machine tag as an input. We will use the selected machine tag since we want to update the selected row from the data grid below. The dialog defines a screen tag called Mac of type machine, which matches the selected machine tag type we configured in the button that opens the dialog. With everything connected, I used the onOpen script to copy the values to each text box. The Cancel button closes current dialog, and the Update Database button creates an update query to set all the columns based on the machine selected. Then it executes an update system function, part of the SV database library. The first parameter is the name of the database connection we will use, and the second parameter is a string containing the query. A message box will be displayed when the operation finishes, and the current dialog will be automatically closed. The refresh button will update the data grid object. The last feature is the free query dialog. The data grid is configured with free query type connection, and it allows changing the query dynamically during runtime. We can achieve it using a string tag, for example, and as soon as this tag changes value, the data grid will execute the query and refresh. We just need to predefine the columns and run a query that returns them. Let's test it. If we remove the initial filter, it loads all the machines. The Close button simply closes the current dialog, and the Create CSV button uses the same query to select from the database and generate a text file in CSV format. It adds the header and the tag values in a table format and saves the file to the application folder. It then asks if the user wants to open the CSV file, and in case the user confirms, it opens the file using Notepad. Let's close some documents and open the next screen, which contains a trend objects that is configured to display historical data of the running times for each machine. On the property grid, I have added the tags that match the tags configured in the tag history document. The buttons on the bottom will filter the trend history based on the duration. I used the name of the object to call the update duration function, passing the number of seconds as a parameter. Each button defines a different number of seconds based on the time range I chose. As soon as we test the running application, we can see values loaded, and we can click the buttons to simulate different historical data. The next feature I will show you is the built-in charts. They are available on the graphics toolbar, and for this demo I used a bar chart and a pie chart for displaying online data retrieved from the database. Both charts were configured to display the current running times for each machine. The chart at the bottom is a line chart and is configured to display historical data. It is also configured with tags on the start and end date to allow filtering using the date and time pickers on the left. Each machine running time tag was added to the line chart, and since these tags are being stored by the tag history document, it will load history depending on the date filter. Let's take a look at the running application. The online charts are updating since the simulation is enabled and the historical line chart has some pre-loaded values. If I update the end date, it automatically loads the last simulated values to the line chart. These charts are a great way to display the data to the users. The next screen displays an external chart using a web browser object, available in the Advanced Objects group. It is set to load the stack.html file located in the web server hosting folder. The Update button will create a new stack.html file. First, it instantiates a structure called machines. Each row represents a machine, so it gets the current values for each tag and updates the machine variable before adding it to the machines list. Then I call the create_html function I wrote in the HTML helper user library, passing the list of machines as a parameter. The create_html function receives the list of machines and calls a second function passing again the machines as parameter. The next function will get the data from the machines and convert it to a string. The getData function will return the machine data in JSON format. This is the format expected by the external JavaScript library I used in this HTML charting demo. Now we have the data ready. Let's pass to the next function, which will actually create the entire HTML file. We can see at this line the data being added to the chart. In the beginning of the file, I also added the script references for the external library. So when user clicks update, we are actually creating an entire new updated HTML file and then reloading the web browser. We can simulate some value changes in the database which will directly reflect on our HTML chart. I saved 55 to the machine 1 running time. If we open the HTML chart, it still has value 25, but as soon as I click update, the value will be updated to 55. We were able to complete an interesting demo using different database connectivities. We went through all the documents in the application, starting with the tags and why they were created. Then we verified different logic created in the services and in the triggers document, responsible for value simulation, data retrieval from the database, and updating the tags. We also saw the tag history document, which stores data in the SQL Server and will be used later by the data grid, the trend, and the line chart. The user functions were also important to the application, written specifically to run queries and generate the HTML charting file. There are still alternatives to communicate with the database, including the audit and trail feature or the database driver, which were not included in this video, and additionally there are other alternatives to using the data grid and the trend object. So feel free to explore the ADISRA SmartView tools and create the best application to your business, or contact the ADISRA support team at any time. Thank you for watching the video until the end. I hope it helps you learn something new and gain fresh insights about ADISRA SmartView. If you have any questions, please contact the ADISRA support team.